Welcome back. In the last video I finished the decking, and in this video we're tackling the soffits and battens ready for the cladding. For both these tasks the DIY is really simple, but there's a lot of nuance worth knowing about to best decide how to go about each, so there's a lot to go through, hence why this video is so long. I've timestamped everything below so you can skip around and find the relevant bits to you. So let's begin with the soffits, and before we get to how I did mine, I actually want to start where this video about constructing a cold roof left off, as the soffits are probably where you want your air to enter and exit to provide the ventilation required to remove moisture from a cold roof design. So quite simply, we need some holes. The most common type of soffit board is UPVC, so the easiest way to achieve this is to use vented soffit board, which has pre-cut holes along its length, and they come in various different colours and widths to suit your overhangs. Of course, there are plenty of other materials. You can use any type of cladding for your soffits, much as you can for your fascia, but to create the vents you'll either need to cut holes similar to the UPVC soffits, or create cutouts and install pre-made vents. Another option is to simply leave a gap. There's lots of variations you can do, but there are a couple of crucial things to get right with all of them. The first is that every joist in the cold roof needs to be ventilated, so either ensure you have at least one vent between each joist, or you could cut holes in the joists, or furring strips if you have them, to allow air to flow from one joist to the next, and that might allow you to only vent between, say, every other joist. The second thing is that the space above the soffits makes a perfect home for wasps to build their nests, so however you go about creating the vents, you'll want to glue or staple insect mesh to the top side of the soffit to stop them getting in. I'll leave a couple of links below. Of course, you may not have any soffits at all. Perhaps you're leaving the bottom of your joist open, as Nick did, which looks great, or maybe you have a box-style garden room where the roof joists stop at the walls. So how do you vent your cold roof with these designs? I'll have a suggestion at the end of the video, but you'll likely work it out as we go along. Now, the sides of the garden room that run parallel with your joists don't need ventilation, and neither does a warm roof construction, so how did I do mine? My first task was to take a Sharpie and mark the breathable membrane below the centre of each joist. This will show me where to nail in the soffits, and also because my joists and studs are perfectly lined up, this will help with positioning the battens later so that they attach to the studs, which I otherwise can't see because of the breathable membrane and OSB. And just in case my electrician had lost the measurements, I marked an X in the middle of two joists where the cables for the lights are located. So for my soffits, I chose the hollow UPVC with these channels in anthracite grey to match my fascias and windows. The boards come in a 30cm wide by up to 5m long boards. The usual way of attaching these boards is having them long ways across the soffit. The two long edges have a tongue and a groove, so if your overhang is wider than 30cm, no problem, they fit together nicely. However, I decided to fit them in short pieces perpendicular to the wall. I've got to credit Graham for this idea, but there are a number of reasons why I thought it was good for my build as well. One, the soffits are very floppy, so to go lengthways I'd have needed at least two other people to hold the soffit while I attach them. Number two, all four sides of my garden room soffit exceed 5 meters, so I'd have needed an H-trim piece at the end of each board to connect to the next. Not the end of the world, I have a joint in my fascia for example, but it's nice for it to be unbroken. 3, going lengthways would have meant having a bunch of pin nails visible in the soffits. Again, I have them in my fascia, maybe not a big deal. 4, my cladding on the front will be horizontal, so I thought switching up the design would look cool. And number 5, because the soffit has these channels, going perpendicular will allow me to vent the walls without leaving a gap at the top of the cladding or going through the soffit. More on this later. So I measured and cut each piece with the handsaw. There are specialised UPVC saws with finer teeth, but as with my fascias and roof trims, I've gone on fine with a wood saw. Be smarter than me though and try to catch the plastic shavings. Now if you remember, before I attached my fascia, I used small strips of 9mm ply to substitute for the soffit in an effort to go back as few steps as possible in order to get my rubber roof on before winter set in. This turned out really well and I was able to just slot the soffit board into the lip of the fascia. The next piece then slots into the first piece, and so on. So the front of the soffit is held up by the lip of the fascia, and I just needed one pin into each joist at the wall side, and it all stays put very nicely. The pins will all be covered by the wall cladding, so it all ends up looking very seamless. Once I got to the end of the soffit, I could cut the last piece to width, and using the expansion space in the lip of the left side fascia, I could slip both pieces in and then make it whole. I did the back and side soffits in exactly the same way, and if I raise the exposure here, you can see the channels run perpendicular to the walls. But you could cut the soffit along its length and match up the channels to the front if you like. To connect the side soffits to the front and the back, I used H-trim, which unfortunately only seems to come in 5-meter lengths, and I can't have used more than 60 centimeters for this job, so I have a whole length left over still. I slid it onto the front soffit, and then the first piece of the side soffit slides in on the other side of the trim. I think it came out really well. This was before my electrician did the second fix, so he cut out the soffits for the lights. These downlights have metal surrounds, so the plan was to spray paint that part with anthracite grey to match the soffits, but as far as my to-do list goes, this task remains right at the bottom. On that note though, if you ever do get any scuffs on your UPVC soffits, fascias or windows, you can buy pens of the same colour to touch them up. Final point on soffits for now is that issue of wasps getting in, and it's a problem I had. They managed to get in the gap between my soffit and wall, so later on I sprayed expanding foam all along the gap to block it off. I just did the front like this as I'd cut the sides and back soffits tighter so it wasn't needed. If you do get wasps at any point, ant powder works really well, so if you see this white patch in future vids, you know what it is. I'll also come back to this junction between the soffits and the battens at the end of the video, as there are a couple of different ways of doing things. Okay, now onto the battens, and first let's look at how my breathable membrane fared given that I left it bare without cladding for longer than I care to admit. You can see that compared to a new piece, the lettering has faded. I've not been able to find out how exactly breathable membrane deteriorates with exposure, but let's recap its 3 functions, as this will lay the groundwork on why we need battens. The first is in the name. It's breathable, so it lets air and water vapour out of the walls from the inside. I doubt it's become any less breathable due to exposure. Second function is that in the other direction from the outside in, it acts as a vapour barrier and therefore stops drafts from the outside, and it stops water vapour getting in as well. And thirdly, it's waterproof, so no rainwater can get through to the OSB or stud-work. This I can test by pouring on some water and seeing if it sheds it or soaked it up. And it seemed to shed it just as well as on a new piece, so I was happy to leave my Tyvek rather than add a new layer. The moral of the story is do as I recommend and not as I do, and just get it clad within 6 months. As I left it so long, I am glad that I went for Tyvek over a cheaper brand like 𝐌𝐚𝐭𝐞𝐫𝐢𝐚. I suspect that the overhang's keeping it dry, and the building being in a shady spot helped its longevity too. So battens are thin strips of wood. They come in a bunch of different sizes, namely 1x2 and 1x1.5 inches. Both of these will do fine. I happen to choose the 1x2 battens. Sometimes you'll see them in blue or red or other colours, but for our purposes, as long as they're pressure treated, any will do the job. The big question is, why do we need battens at all? Why not just attach the cladding straight to the walls? Well, you know I like a list, so here's 4 reasons. 1, it's possible with driving rain that water can get behind the cladding, and so having a gap allows the water to run down and out the bottom. 2, if you have timber cladding and didn't have a gap, then any water that gets behind will take a long time to dry and potentially cause decay of your cladding. Additionally, if the front of your cladding dries in the sun and air, but the back stays wet, then this can cause cupping of your cladding as the back expands. So having the gap created by the battens allows backside drying of the cladding and prevents this cupping. For points 1 and 2, this system is known as a rain screen. I suspect that if you have roof overhangs like me, it's very unlikely we're going to get much water behind the cladding, except for the occasional Forrest Gump sideways rain. 3, the slow-moving air behind the cladding provides another layer of insulation as it slows the removal of warmth emanating from the building, in the same way that for the 95% of you that watch this channel, the hair on your arms traps a layer of warm air close to the skin. And 4, this is the most critical. The airspace allows removal of water vapour escaping out of the walls because as it moves upwards and escapes from the top of the cladding, it then draws in air from the bottom. This type of ventilation is known as the chimney or stack effect. For very tall buildings, the air pressure and the temperature differentials between the top and the bottom also drive this cyclical process. As an aside, and this really doesn't apply to us building 1-story home offices in our gardens, but what do you think happens when you combine flammable core cladding with a very strong stack effect? So we're very zoomed in on the detail. Let's zoom out and go big picture. If we look at the whole system from the inside out, in winter we've got a vapour barrier slowing the entry of water vapour into the wall, the breathable membrane allowing any vapour that does get into the wall out into the void behind the cladding, and then this warm moist air that does escape moves upwards, escaping from the top, and in doing so draws cooler air from the bottom, creating our stack effect. pretty cool. Next, let's compare vertical versus horizontal cladding, as this will affect how we do our battens. You can see that from my original sketches that I always intended to have horizontal cladding, at least on the front. And my thoughts behind this were that because my building is on the taller side at 3 meters, horizontal cladding would help make it look less tall and imposing than vertical cladding. But I'm not sure it's true. In fact, it might be the opposite. These shapes are identical, just rotated. You can make up your own mind if one looks taller or wider than the other. Aesthetics aside, I think that going vertically has a lot of pros over horizontal cladding. One, unless you have a small garden room, going vertically will mean that you're dealing with shorter boards, which are easier to store, carry, and attach. You also won't have any joints between planks like I have, so it's a bit more seamless. 2, if you have a raised timber floor and want to hide the gap underneath, and you've not got any decking, it's easier with vertical cladding as you just extend the boards down close to the ground. On the other hand, if your cladding is timber, you are exposing the more vulnerable end grain to rain splashback. 3, another pro for vertical is that you'll only have to do one cutout per board to fit around windows and doors. You can imagine how tricky it was to cut this plank around 2 windowsills in order to avoid having a joint. 4, I think it's easier to keep shorter vertical boards plumb than it is long horizontal ones level. And 5, this is a minor one, but you have a little more choice in timber cladding profiles with vertical. For example, this profile can't be used horizontally because water would sit on the flat bit, but that's not an issue with vertical. So it seems pretty one-sided. However, vertical cladding does complicate how the batten should be done because vertical cladding requires horizontal battens to fix to. So given that we need that vertical ventilation we talked about, this generally requires cross-battening. So vertical battens first, then horizontal battens in front, and then finally the vertical cladding in front of that. To go without any vertical battens would block your airflow from bottom to top, and any water that does get behind can't escape downwards. I do think that if you were to just put horizontal battens directly on the walls and you have timber cladding, moisture will work its way out through the cladding. If it didn't, then we'd have kind of screwed ourselves putting OSB on the walls. The key thing is that we want moisture to escape the walls faster than it enters so there's no build-up. So if you have a tight vapor barrier on the inside of the wall, that will help, but cross-battening is definitely the optimal way of doing things. If you really can't spare the extra wall width for cross-battening and you really want vertical cladding, here's a couple of ideas to get some of the benefits of cross-battening without actually doing it. The first one is you could use strip wood moulding in place of your vertical battens. These come in 6mm, which will give you a bit of ventilation and a route for water to work its way down. Or if you have a table saw, you could rip 9 or 12mm external grade plywood. Ideally you want a gap of 20mm plus, but something is better than nothing, right? The other idea I had is offsetting the horizontal battens so there are gaps between them for water and air to move around. This would work well for secret fix cladding profiles where you can't see the nails or screws, but not for face fixing because all your visible fixings would be misaligned. Now there are a couple of exceptions where the style of the cladding can actually provide the vertical gap for you, and therefore you don't need any vertical battens. So the first is metal sheeting, which I'll talk about in a future video, but because of the wavy profile, you can get that ventilation gap with just horizontal battens. Another example is board on board, where you attach the first layer, leaving gaps between the boards, and then cover it with another layer. This gives you the ventilation required, again without the need for vertical battens. In this diagram, you can see the difference and how the batten should be done depending on how you're doing your vertical cladding. On both, it does show that the battens should be cut with an angle to shed water, whether forward or backwards, but unless you can source them pre-cut, to me it seems like a lot of effort. As I said before, I doubt much water will get behind the cladding. So to sum up, lots of advantages to vertical cladding, but you have to think more carefully about your battens. Before we move on, I want to cater to those of you watching from further afield, and I'm going to use April Wilkerson, a very inspiring woodworker who built an absolute monster of a workshop on her land in Texas, as an example. So here you can see that she hasn't used any battens before attaching her cement board lap siding. And I asked the question why, and quite a few others did too. We didn't get an answer, which is fine, she's a busy lady, but I think I can say why. And I've touched on this before. Essentially, because the Texan weather is hot and humid for a lot of the year, the wall system needs to work in reverse. The Tyvek works as a vapor barrier to the outside, preventing moisture getting into the air-conditioned interior, and there's no vapor barrier internally. If we move further north to mid-latitude US, excluding microclimates, where you're heating and cooling for equal parts of the year, there is a school of thought that says it's best not to have an internal vapor barrier and just let the wall breathe as much as possible, which battens will help with. For northern US, Canada, and northern Europe, it seems pretty clear-cut that timber frame buildings will benefit from the system of an internal vapor barrier, an external breathable membrane, and battens to allow ventilation. ventilation and removal of moisture. The climate may change in the coming decades, as might construction science, so this method may change too. To play devil's advocate, if you don't have an internal vapor barrier and don't attach battens, would your garden room fail in any way? I honestly don't know, but my gut says not, especially if you've used PIR insulation, which is moisture resistant. Personally though, I like that the science makes sense to do these things. So we've established that we need ventilation at the bottom and top of the cladding, but this means insects can potentially get behind the cladding too, so the general consensus is that you need to attach insect mesh. For most of the cladding, I took the risk of going without, my reasoning being that the space is probably too small for a wasp's nest, especially as I'm only using vertical battens, and what does it matter if a few spiders make their home there? We'll have to see how that works out. It is probably a good idea though, so how is it done? Focusing on just the bottom for now. Cut a strip of insect mesh as long as your wall is wide and staple in a few places to the bottom of your wall. Then attach your vertical battens and wrap the insect mesh under and staple to the front of the battens. If you've got horizontal battens, you'd staple to the front of the bottom row. Then your vertical cladding goes on after and the insect mesh is hidden. Some cladding systems come with a starter rail that goes under the battens and has small holes for ventilation while keeping insects out, so it does the job for you. Okay, let's do it. As always, where I cut a batten, I dipped it in wood preserver. To attach, I lined up the centre of the batten with the marks I made earlier, and I use a mixture of 50mm nails and screws to attach them. So the nail here is going through the batten, through the OSB into the stud. Unless you've used 18mm OSB sheathing, you will probably want your battens to attach to your studs. So when you're building your walls, it's good to know what cladding you'll be using, as the frequency of fixings ranges from 400mm to 1.2 meters for different types of cladding. So for example, if you know you're going to be using cladding that only requires a fixing every 600mm, you could set your wall studs on 600mm centres. As you know, mine are 16 inches, which is basically 400mm. With the first nail in, I could then use my level to make sure the batten is plumb, and then added around 5 fixings per batten. The bottom of each batten is lifted off slightly from my decking so it doesn't get wet. For the battens on the sides of the windows and doors, I made sure they were plumb rather than just following the edge of the OSB. It's useful to use a scrap piece of cladding or something of the same width to just check that it will sit at a clean 90 degrees. If you remember, my openings were about 5 to 10mm bigger than the actual windows and doors to allow fitting, and I spray foamed and sealed the gap between. This gap will now be nicely covered by the cladding. The reason I had my windows quite far forward within the window reveal was so that I would have more space for the plasterboard on the inside reveal, and then the battens create the reveal on the outside. If you're cross-battening, you get a wider external reveal, which I think looks good, but bear in mind when ordering your windows and doors that you may need a wider sill than I had to accommodate the width of 2 battens plus cladding. If, like me, you have patio doors with external hinges, before you attach the battens, make sure you're leaving enough room to slip in the cladding reveal trim, or whatever it's called, between the batten and the hinges. Now what about under the windows, because they block the flow of air from bottom to top? If you're cross-battening, no problem, the air will find its way up the side of the window, but with vertical battens only, you either have to have them a little short so there's a gap under the sill for air to move across, or you can leave a small gap in the cladding. I decided on the latter. If you do the same and are worried about insects, then you'll want insect mesh here too. Then finally, above the windows and doors, we kind of have the same issue, but at the bottom, because your trim piece will block air getting in. So unless you want to have holes or vents in it, which I didn't, you may as well put a horizontal batten across to fix into. I'm not too concerned about this because 1, warm moist air moves upwards and it's close to the top of the cladding. 2, I think there'll be a reasonable amount of air exchange at the top. And 3, it's so close to the overhangs I doubt water can get behind. I could have had a gap at the bottom of the vertical battens, but the problem with that is that I don't know where my fixing point for my cladding will land, so I could end up not being able to attach that section of cladding. Again, with vertical cladding and cross-battening, this isn't an issue. Next, let's talk about how we get the air out of the top of the cladding. As I said earlier, one reason why I orientated my soffits like I did was to have the channels work for me in this regard. And you can do the same if you're using cladding boards as your soffit material, as long as it's fixed perpendicular to the walls. If, however, you're fixing your soffit parallel with the wall, or your soffits don't have any channels or grooves, another method is to leave a small gap at the top of the cladding. This tends to be the proper way to do it and works very well for a 2-story plus building, and even with a garden room it may not be too noticeable when looking up at it, but maybe it's not so desirable. But if you have a cold roof and vents in your soffit, then you could use those holes to vent your cladding. To do this, you'd have your battens running all the way up to the roof overhang, soffit in front, and then clad up to it. Alternatively, as well as the battens, you could clad all the way to the top and neaten the intersection with the soffit with some J-trim. Doing things this way, the air will travel up between the battens, into the soffit and out of the vents. As this is an opening to the soffit, you'll either want insect mesh at the top or the bottom, or possibly both. So this idea of linking the battens to the soffits can be used for something I alluded to in my cold roof video, which is that for box-style garden rooms without roof overhangs and vented soffits, how do you vent a cold roof? You don't want to ruin the look of the front of the building with vents in the cladding, so instead I think you could achieve much the same with air moving up behind the cladding into the joist and travelling across the roof. I don't think that the air would travel back down on the other side of the building effectively, so you will want vents on your cladding at the back, but in most circumstances you won't be looking at the back of the building. Is it going to be as free-flowing as venting through the soffits? Probably not, but I think it would work well enough. Okay, I want to briefly touch on electrics. You can see here that I have this cable coming out for the alarm, as I obviously wasn't specific enough that I didn't want a big alarm box on the front of my garden room, and instead wanted it on the side. So my electrician rerouted this from the other side of the door, but it still needed to travel around the battens to reach the outer alarm, which begs the question, why not have all your electrics within the battens? And on the face of it, it seems like the perfect place. It's out of the way of the insulation, no conduits are required, you don't have to cut through stud work, and there's no issue with current carrying capacity, and you don't have to increase cable size to compensate. It's ideal. So I've asked a bunch of electricians who have happened to email me whether this is okay, and each time they say it's an issue with the zones. If you sold the house and the next person decides the garden room would look nice with a hanging basket, they may get a little shock, best case scenario. I suppose though, if you have electrics on the back side of your insulation near the outside of the wall, a nail from the outside could still reach them despite being within the regs. I'd love to get some more opinions on this though, so if you are an electrician, let us know your thoughts below. Let's end this video on build order. Is there a perfect order of building a garden room? I thought about this a fair bit and I don't think there is, because it's influenced by style of garden room, types of material, time of year, and you may be waiting for supplies and want to get on with other tasks. However, there are a couple of lessons from my build which are no doubt obvious in hindsight. The first is that if you're using UPVC soffits, they're super quick to install, so it's easy to do them before you fit your fascia. The second is to do your battens before the electrics and plumbing, if indeed they are internal. I was very nervous that I might hit a pipe with a nail, so I was regularly checking against photos of the inside to make sure I stayed away from them. Okay, that's a wrap. As I said at the beginning of the video, the DIY is super easy, there's just a lot of nuance to these tasks. And it's hard to say whether all of these considerations are a bit excessive for a garden room, and I do consider myself a pragmatist, so for example, if you decide to only use horizontal battens because you think, well, I'm not going to be using the garden room that much in winter, my vapor barrier is nice and tight, my cladding is timber and will let some moisture out, and my overhangs will stop rain getting behind the cladding, at least you're making that judgment call with all the knowledge at hand. Next time, we'll start with the cladding. It's a short video you'll be relieved to hear after this one, but will hopefully deliver a ton of value. I'll work on that, you do some building, and we'll meet back there. See ya.